Good morning, everyone. We're going to be talking about practicing proofs. We started this before the break, so this is kind of just a refresher. It's going to also help you do your assignment in Otis today. So our essential question, how do I complete 2-column proofs? And then our learning goal is I can prove a pair of triangles are congruent using corresponding pairs of sides and corresponding pairs of angles. So the proofs today, not a lot of them are going to hit this learning goal. It's something we're building towards. We have to be able to do 2-column proofs before we can get into all the stuff with the triangles. So it's really working towards that goal. Also, there is a notes Google Doc in Google Classroom. So feel free to just type right into that. You don't need to make a copy or anything fancy unless you want your own notes. And that's if you want to do it on your own paper, that's fine, of course. All right. So number 1, fill in the missing reasons for the proof below. We are given, and I'm going to actually be using green today. We are given the measure of angle MJK and MJL are a linear pair. So right up there we have a linear pair of angles. And then we are supposed to prove that the 2 angles are also then supplementary. It's something that we have taken for granted, but here we're going to prove that it actually works. And just a reminder that supplementary means that they add up to 180 degrees. That's what we're going for. All right, and so right here we have the reasons bank. So these are the 4 reasons that we're going to fill into the different boxes that don't have reasons. On your assignment today, there will be more reasons than fit in the blanks. Some reasons get used more than once, and some won't get used at all. But you do have a bank of reasons to choose from. So number 1, angle MJK and MJL are a linear pair. We know that because that is given. Remember, almost always your first thing is going to be what's given. And we can see that's right at the top. Then we have ray. Remember, this is a ray because it has an arrow. Ray JL, and it always gives us the end point first and then the direction of the arrow. So JL, which on our picture would be right here, JL. Okay. And ray JK are opposite rays. So opposite means they start at the same point and they go in the exact opposite direction. So our reason for that, we have some things up here. Was that given to us? No, we already used the given. Shouldn't cross it out that way. Should have crossed it out when we did it. We already used the given, so we know that one's done. For this set of notes, we're only going to use each one once. We have angle addition postulate, definition of linear pair, and then substitution. So angle addition means that we added some things together. We didn't add anything really. You can see later in our things, there's actually addition signs. So we'll probably save that for later. There's no actual addition here. Just going to highlight that little arrow for the ray. Okay, so probably not the angle addition postulate. Here we have opposite rays together. That's actually how we define a linear pair. It's 2 angles that make a line, and angles are created from rays. So this is actually going to be our definition of linear pair. Then the next one says JL and JK form a ray JL and ray JK form a straight line, and that is the definition of opposite rays. So we just said they were opposite and then our reason was they're a linear pair. So you'll notice our first statement said linear pair. Then our next in the next line, that linear pair. I'm going to highlight this for us so we can kind of see this pattern. We said, whoopsie, sorry. So we said in the first statement, we had a linear pair. Then we made a new statement, and our reason was because it's a linear pair. Then in our next one, we make a new statement. And so actually I'm going to change colors here so we can kind of see what I'm talking about, hopefully. Then the next one, we said our statement was opposite rays. And then notice we use that as our reason for the next thing. So we start with saying, hey, something's a linear pair. And then we make a new statement, and our reason is the fact that it was a linear pair. And then, excuse me here while I'm trying to get this pen to do the thing I want it to do. Fantastic. Okay, so then the next one, we make a statement about opposite rays. And then our next statement, statement 3, is something else, but we use that fact that we said it was an opposite ray as our reasoning, how we were able to make that next statement. So it's a progression. All right, then we have ray JL and ray JK form a straight line, definition of opposite rays. Then I'm going to do that highlighting thing one more time because we see it again. Right, I'm trying to pick a highlighter color. Let's see. Maybe I'll do green. We have a straight line, and we have that showing up here in our reason as a straight angle. So a straight line and a straight angle, those two are tied together as well. So nice progression here. It won't always look quite like this, but I just want to point out that it's one step at a time. Because it's this, then that's our reason. So we say it, then that's our reason. We say it, then that's our reason. Again, it won't always work that way, but definitely we can see that pattern here. Okay, so the next one was the measure of LJK, which is already highlighted on my picture in green. LJK is a straight angle, it's 180 degrees. So then we can say the measure of MJK, which I'm going to mark for us, MJK, it's right there, plus the measure of MJL. So MJL is this one right here. When I add those two up, I get the measure of the whole angle, which is the LJK. Okay, and the way that we know that is true, that one, I forgot to cross out definition of linear pair. The way we know that's true is what's called the angle addition postulate. It says if I add two parts or two angles, it gives me the larger angle. So the straight line was divided into two smaller angles. So if I add up the parts, it gives me the whole. Angle addition postulate. Okay, then there's also something called segment addition postulate, which is the same. If you add up the parts, then it gives you the whole length of the segment. All right, so then if we look from 5 to 6, we notice that it says the measure of the angle plus the measure of the angle. So all of this is matchy-matchy, except for what it equals. So notice we changed what it equals. Okay, so the way that we were able to do that is actually back up here in step 4, we said the measure of LJK is equal to 180 degrees. So instead of saying LJK, we said instead we're going to say 180 because we know those two are equal. So this would be substitution. And then the last one, then we have the measure, angle MJK and MJL are supplementary. And the way that we know that is right here in step 6, when we said the two angles add up to 180, that is our definition of supplementary angles. So hopefully that kind of helps to remind us about how we're going to do some proofs. We're going to do one more. So here we go to the next one. All right, so fill in the missing reasons for the proof below. Again, we have a nice reasons bank, and I will tell you for this activity, all of the reasons are going to be used. Oh, this one, they might get used more than once. So they might be used more than once, but these are all the reasons. There are definitely all of them will get used. All right, so we're given that P is parallel to Q, and they even marked it on our diagram for us right there. P is parallel to Q. And we're supposed to prove that the measure of angle 3 equals the measure of angle 5. So we want to know that this one is equal to this one. And I just marked that, but I'm going to erase it because we don't know that it's true. Okay, we don't know that it's true. We want to prove that it's true. So we need to show it some other way. All right, so we have P parallel to Q. The reason for that one is given, and since that is my only given, I'm going to go ahead and cross it out. So this one is given. That's the only thing we were given. Then we have angle 3 and angle 6 are supplementary. So I'm going to look at angle 3 and angle 6 are supplementary. So how would we know that? So I just marked two angles, and I'm telling you they're supplementary. They add up to 180. How do we know that? So there's a couple things up here that might look attractive. Like right away, since I said supplementary, I see supplementary angles, definition of that. However, those two angles, there's nothing about them that tells us just by the picture that they're supplementary. So we're not saying they add up to 180. There's not like the angles listed there adding up to 180, like number 3, where it says an angle plus an angle equals 180. That would be more like definition. We also have some other things that could linear pair, although 3 and 6 are not a linear pair. So actually the one we're going to use is way up here at the top, same side interior angles. Remember, we have parallel lines. Those are on the same side of line T. They're both on the right of that transversal, and they are both inside the parallel lines. So that would be same side interior angles. So I'm going to list that, same side interior angles. Great. Then the next one says, so we went from 3 and 6 are supplementary to actually writing what that means. If they're supplementary, it means the measure of angle 3 plus the measure of angle 6 is 180. That would be our definition of supplementary angles. Notice I'm going to abbreviate. Okay, great. Then I'm really not happy with that U. The things that bother me sometimes. Okay, then let's go to the next one. So if angles are supplementary by definition, we can say that the measure of one plus the measure of the other equals 180. So definition. Then we have, now that we know they add up to 180, we're actually going to shift a little bit, and we're going to say 5 and 6 are a linear pair. So 5, I'm going to not give it a true marking here. I'm just going to kind of underline it for us. Angle 5 and 6 are a linear pair. And this one is a little bit more difficult in terms of the reason. So I'm just going to help us that what we're looking for is basically because of how they are drawn, they create a line. So we're going to say this is the linear pair theorem. I would call it definition of linear pair, but this either way, linear pair theorem, which is really more involved, but I'm going to also list this as definition of linear pair, which isn't in your list. So we're going to stick with the list, and it says linear pair theorem. So because that is basically just because of how they're drawn, they create a straight line. Great. Then we have angle 5 and angle 6 are supplementary. Well, how did we know they were supplementary? We knew that because they're a linear pair. So we're going to actually use that same reason. This is the actual linear pair theorem, which says basically if you have a linear pair, then they're supplementary. That's the theorem. Okay. Then number 6, we went from saying they're supplementary, and here we're going to say the measure of 5 and the measure of 6 add up to 180. That's going to be our definition of supplementary angles again. When we say, hey, they're supplementary, and then our next thing says they add up to 180, the reason we know they add up to 180 is because they were supplementary. Those are tied together. So saying they're supplementary and showing they add up to 180. All right, then number 7, then we have, this part is really important that we see where this came from. So I'm going to switch to my highlighter, and I'm going to switch colors. Okay, so if I go up here, I have the measure of angle 3 plus the measure of angle 6. I want to highlight that this says the measure of angle 3 plus the measure of angle 6. Fantastic. All right, then I'm going to go and highlight in orange. I have the measure of angle 5 plus the measure of angle 6, the measure of angle 5 plus the measure of angle 6. So how are we able to say that those two things are equal? So I kind of highlighted where they came from. And so now I want us to see, where did we get that? How are we able to say that they are equal? So that comes from what I already have circled, that the orange, measure of angle 5 plus measure of angle 6 equals 180. And the yellow, angle 3 plus angle 6, the measures equal 180. So they equal the same thing. So this is actually going to be transitive property. That's the sandwich property. When they are equal to the same thing, then the parts themselves are equal. So the orange and the yellow also have to be equal. So this is transitive property. And look back in previous notes for more information about that. But roughly the version of transitive property that I usually refer to is if A equals B and B equals C, then A equals C. So here you can see the matching parts. Both A and C are equal to the B, or in our case, the orange and the yellow are both equal to 180. Then the other parts, the A and the C, have to be equal, or the orange and the yellow have to be equal. Okay, then our last one, the measure of angle 3 equals the measure of angle 5. In your notes, you have an extra blank statement box. That is intentional because I'm going to sneak it in, but you guys can just write it in. Basically, what we did, if you see, we have angle 3 and angle 5, and then we have this measure of angle 6 and measure of angle 6. So we do something that we use in solving equations. We say, hey, I don't want that measure of angle 6 anymore, so I'm going to subtract the measure of angle 6, but I have to do it to both sides. And so that's what you guys can write in that blank box on your notes. And when I do that, these cancel out, and that's how I'm left with angle 3 and angle 5 are equal. Since I did subtraction up here at the top, that's the subtraction property of equality. Basically means you can subtract something from both sides and you'll get a true equal equation. All right, so that's it. Hopefully that helps give you guys a little bit of what you're doing in your Otis. I think the Otis will probably be a bit easier, but that's it. Have a great day.